Greetings, my name is Filip Leschinger and this is a brief introduction to a new plugin for SignalPlant software, the Deep Player. Our new plugin loads a deep learning model in ONNX format and uses signals as the model input. And after inference, model outputs can be used as new signals. And now I will show you how it works. For this tutorial, we will need the SignalPlant, which can be downloaded from the signalplant.org website. I will also use a machine learning model from the website. Here is the package containing 4 demonstration models. I will also use a single file from the PTB database from the Physionet server. So now I'm starting SignalPlant. I will load a signal, 12 lead ECG, sampled at 500 Hz. Here we are. The signal is loaded and now let's run the Deep Player plugin. It's located in Menu, Plugins, Generate Data and Deep Player. This is the plugin window. Although it contains many controls, the workflow is like in other SignalPlant plugins. First, I will associate signals as plugin inputs. Our model requires 12 lead ECG, so I need these 12 channels. When I scroll or zoom in the main SignalPlant window, the preview in the plugin is also refreshed. And now let's load the deep learning model. This is a unit model to detect QRS complexes in 12 lead ECG. It's loading now. And here we are. Let's discover important facts about a model. Here is the input and output dimension. One example in a batch, 12 channels and 1500 samples. This is the length of the inference window. You can see that the value was transferred to the proper control here. And here we see our consecutive inference windows. In the preview panel, we see model outputs. 2 channels telling us the probability of whether any QRS is there or not. We will require just the second channel. And look what happens when I scroll signals to the left or right. You see that outputs are instantly recomputed. You can also notice disturbations in outputs near inference window borders. For example here. So I can let inference windows overlap a bit. Now it's clear. And now I can check whether this model would work even on premature contractions. Let's find them. It should be more to the right. Here we are. Oh, that's fantastic. My colleague did a good job. She prepared very good model. Nice. Finally, I can export model outputs into SignalPlant to detect peaks or measure network response or whatever. So I will select Process. And here are our outputs from the deep neural network. This brief introduction is near the end and I would like to thank you for your attention. I would like to thank my colleagues from our scientific group for preparing supplied models like the one I just showed. Also, I would like to thank my friends from the Kismet group at the Darmstadt University in Germany for developing one of the supplied models. They also prepared a beautiful Jupyter notebook with a complete code to build a new deep learning model, including ONNX export. So I hope that you will find the deep layer useful, and I wish you a lot of fun with signals and deep learning. Goodbye.